Right, good morning, ladies and gentlemen. Hello. Is it just me or is there 4th of July behind me? Okay, so I have a request. You can see that, it's behind me. If it catches on fire, please let me know. Okay, looks like we need some space. Everybody who's got a vacant seat next to them, please raise your hand. Those standing in the back, please come. Sitting on the ground, please come. Do not sit on the aisles, please. Keep your hands up if you have a seat next to you. There's lots of seats. Okay, it still looks like we might be doing attendance today, so everybody on an aisle, if you could please look down and see which row number you're in or which row letter you're in. Tell the person next to you. Okay, time to get started. I can see plenty of seats on this side. If you would walk over, please, and find seats on this side. Thank you. As usual, we start with announcements, but before that, I'd like to give you a little picture of today's lecture. The last couple of lectures have been giving you some methods for dealing with data sets. And our data sets are usually visualized in the form of tables. From that, we can extract arrays of data to work with, and today we'll talk about more ways of working with tables. And once we have finished the basic techniques, what we'll do is we'll take a substantial example and look at some data, do some cleaning up in the beginning, and then try to see how we can answer questions about our data using the methods that we have learned, and how those methods then suggest other questions that we might ask. So that's the goal today. But before that, some administrative stuff. Announcements. So homework 2. The announcements are usually very standard. We are on our regular schedule. Homework 2 has been released. It's due on Thursday. If you turn it in on Wednesday, you get an extra point. A few more seats down here. I can see some in the front. Small group tutoring on the website. There is, on the announcement section, there is a link to a Piazza post about this. It is for those who feel that they might benefit from sessions in groups of 2 or 3 students with 1 tutor or GSI to go over some stuff. So please look at that Piazza post and sign up if you feel that it will be helpful. I do have something to say about enrollments. So Friday was a deadline of some kind, and a lot happened to the waiting list. And so now we're down to a few students per lab on the waiting list. Stick it out for 1 more week. It's hard for me to make predictions. There are a couple of labs that have waiting lists of 5, 6, 7 students. People at the bottom of those waiting lists, it's not looking good. But there are many, many labs where there is just 1 student on the wait list. And, people are still making up their minds about classes. And so we might be able to incorporate those students. All right. Any administrative questions? Yes. What do you do if your tutoring session is today and the location hasn't been determined? First, you give your professor an opportunity to apologize to you for that. So I'm sorry about that. Please send a Piazza post. Where do I go? Thank you. More questions? Yes. This is a very difficult thing for students. Please email your GSI. So what happens is when you sign on to Cal Central, I think the moment you sign on, you see where you are on the waiting list, and then after that, you don't get that information again. But I think your GSI has it, so please email. GSIs have access to the rosters. So email the GSI. All right. So tables are the fundamental construct of this of our programming environment for doing data analysis. And so we are going to be talking a lot about tables, and at the risk of making you roll your eyes, I am going to go through exactly what a table is again, because we're going to look at another aspect that we haven't looked at before. So you know that a table is a sequence of labeled columns. The labels are strings, and they describe the attribute that is represented in a particular column. Each row corresponds to an individual whose attributes you are measuring. And so we've spent a lot of time working with columns, and they will be the most fundamental aspects of the table that we work with. But rows are also interesting. A row corresponds to an individual and all of that individual's attributes. So today we will, in a little while, talk a little bit about rows and then get to dealing with doing a particular data analysis. Table methods, this is a recap. We know how to create tables. You can start with an empty table and do with column, or you can start with a table that's in a file somewhere and use read table. So you get started. You can take an existing table and do with column and then extend that. The labels method tells you what all the column labels are in case they've gone too far up your notebook for you to remember. The relabeled method allows you to change the label. If you don't like the label, you can change it to a different string. You can refer to columns by their labels. So, for example, age or player or position or salary. Or you can refer to a column by its index. Index 0 corresponds to the leftmost column. Then index 1, index 2, and so on and so forth. So all of these methods, well, not labels, but all of these other methods create tables. If you actually want to access the data in the column because you want to do, for example, numerical operations on it, then you use column. It takes the label and it gives you the data as an array for you to work with. And then because it's an array, you can do array operations on it. You can create subsets of your table, subsets of columns, by using select and drop. This we have done a couple of times now, and I am actually not going to do a demo just of this, but I will move on to the next one. And is there any questions about this? Yeah. Is there a difference between bracket indexing and using dot item? Okay, so data 8 note, we haven't done and we won't be doing bracket indexing, but I'll answer your question. Bracket indexing allows you to get a range, yes, from here to there. Dot item gives you 1. All right, so you do dot item 7 and you'll get index 7. Okay, you've also learned how to deal with rows. Sort rearranges all the rows into, by default, increasing order of the column that you specified. If you want decreasing order, you have to say descending equals true. So it gives you a table back, and the table is the original table with permuted rows. Permuted means rearranged. Take gives you a table with just the rows that you specified in as the arguments. Where gives you another table with just the rows that satisfy a condition that you specified. So you remember that we did where, what was it? I think it was movies, and it was the year in which they were released, and we did where year are below 2000 or something like that, and we got all the movies that were in years, wherever the start was, to 1999, and so on. So these were methods that give you tables with a subset of the rows. And the last line I showed you yesterday, and the question was asked by somebody that was you. Yes, so this is person who's faking me out by sitting in the second row now instead of the first row. So the student asked, you have shown us how to extend a table by columns. Can you also extend a table by rows? And I had said yes, but we never quite got to that. So what we're going to do today is we're going to start out by building a table by rows, and then we'll move on to the census. But before we do that, what I'd like to do is I'd like to go back to the picture of a table, and I'd like you to talk to your neighbor and identify the essential difference between the column and a row. And please don't tell me one goes down, the other one goes side to side. Right? The essential difference between a column and a row as far as type is concerned. What do you see? All right. Any suggestions? What's the big difference? Yes?
I'd say the rows are kind of exhaustive, and the columns are the data types of attributes of the object.
Okay, so that's a terrific answer, which says that the rows represent a single individual and all the attributes of that individual, whereas the column represents a single attribute and the values of that attribute for all the different individuals. That is true. As Python objects, what's the difference between them? Anybody? What's a column? Yeah. Yes, exactly. Terrific. So the answer was that each column has the same kind of data, so it has the same type, and the rows have a bunch of different types of data. The column represents a single attribute. So, for example, area is just a number. Everything has a numerical area, and the name of the state is a string. So all the names are strings. A row corresponds to, for each state, its name, its code, and its area. So those all have different types. Arrays have to have all elements of the same type. Columns are arrays, but rows clearly are not. They can't be. So they're a different kind of thing. And in order to construct a row, I need to talk to you about a different kind of sequence than an array. Actually, in some sense, a more simple one. It's a list. And a list is any generic sequence. So it's a sequence of values, but the values can have different types. And a list is written by enclosing it in hard brackets. You see those square brackets? Okay, so this thing is a list. And it has 1, 2, 3 elements in it. That is a number. That is a string. This thing is a table. That is a very bizarre list. And by the way, there's a list being used to construct this table. I'll come to that in a moment. I don't actually see a genuine practical use for this particular list. It's just to give you a sense that you can make a list consisting of any type of object that you want. And we're going to use these to create table rows. We're also going to use them we're also going to see how you can use them to create table columns, as here. But once you use a list to create a column, necessarily that list must have elements of the same kind, otherwise you won't get a column. Once the column is made, it will be automatically turned into an array. So we're going to see all that now. And I'll start with a table that we created last time. So we had streets outside of campus. Okay, so I want to show you a way of using with column that we haven't before. Thus far, we've just said, column label and then the array for the column. You can extend by two or three columns or as many columns as you want at once. So the first column, name of street. The array streets, note another comma. And then the next one is what we do. We did blocks from campus, I think. So doing that, that's an assignment statement. You can't see anything if you want to look at the table. You get that. Questions about the use of with column. Notice the separation into different lines. You don't have to do that. You can write it all out as one long string, but it is really difficult to read that way. So this one can be broken up into lines. Okay. Yes? You want the label of a particular column? Yeah. Yes, there is. Let me finish the circle of ideas. I will show you where to find the answers to all of these questions. All right. So what I'd like to do now is I would like to look at a particular row. And rows have indices just like columns have indices. And row indices also start at 0. So row 0 corresponds to Bancroft, 1 corresponds to Durant, and so on and so forth. So if I look at what row 0 is, that is a row object. Okay? And it just says, in that row, the street attribute, the value of the street attribute is Bancroft, and the value of the box from campus attribute is 0. So now supposing I wanted to add another street. What's the next one? Dwight? Yeah. Supposing I wanted to add another street, I could do this. With row now, and I just have to say what the elements are, and I have to include them. I will include them in a list. So list starts with square brackets. The name of the street is Dwight, and blocks from campus is 4. So list, not array, because Dwight and 4 have 2 different types. And now you have grown this table just as a... Actually, questions about with row, this particular use? There will be ways later to tack on a table to the bottom of your table as long as it has the same column names. Yes? The row object is not a list. It's a row object. It's a different thing. It was created for this table class. So actually, let me just... shall we try this? Let's just be absolutely certain about that. It is a row. Okay. Now, what I've done is I've created this table. When you do something like this, notice there's no assignment statement. It's just take the tables outside and do something to it. That is, I think of as a transient operation. You create that table, it's right there, but the next time you call Southside, it's not going to be there, that last row, because you haven't actually assigned this table to any particular name. So if you want to grow your table, a classic way is to just assign the new table to the old name, and the assignment statement doesn't have an output that you can see, so you call the name of the table, and there it is. And this is something that you have now seen many, many times in lab. Okay. We know how to extend by column, and so I'm going to create a column called one way, and its values I am going to present as a list. Okay, so Bancroft is one way. Durant, this is near campus. Channing isn't. Haste is, and Dwight is. What is the difference between this line that I have here and this with column with this use of with column? So take a look at this one. NP.A range here, streets was up here. And what we're doing now is this. What's the difference? So with column, you have the label of the column, that's fine. What's that object? It's a list. It's not an array. All right, so this is the first time we are creating a column by using a list. If I look at that column, what's the index? 2. The new column has index 2, 0, 1, 2. Notice that the list that I typed in has been converted into an array. In a table, all columns are going to be arrays regardless of how you entered them. Okay. Questions? Yes, so basically it will create an array for you. And so if you try to create an array with objects of different types, it's just going to decide basically you forgot to type in the quotes. All right. So this is it. You know how to deal with tables now. And so you're on your way to doing any number of analyses. I just want to make sure that we're all on the same page here. So here is a discussion question for you. There's an NBA table, and it has columns name, position, and salary. Every row corresponds to a player. Create an array containing the names of all point guards, that's a particular position, who make more than $15 million a year. You can assume that the salaries are in millions of dollars. So here's your task. You have to write one line of code to produce this array. And before you start, you should look and see, okay, they're asking me to give what type of object? You're being asked for an array. Yes? Among all your table methods, there is exactly one that produces an array. That's the one you have to apply to the right table. Talk to the people around you, figure it out. One line. Okay, everybody. Which table method gives you an array and not a table? Column. Dot column. You have to extract a particular column of some table. So you have to first create that table. So the table is going to be some rows of NBA. And so what table methods are you going to use to create this new table that you're going to work with? Names of all point guards who earn more than, so all the rows that satisfy a particular kind of position and a particular kind of salary. Yes? There is exactly one table method that you know that gives you tables with rows satisfying conditions. Which is that? That is where. Okay, this is how you make your decisions. And so somebody give me a suggestion? So I'll start you off. I take my table NBA dot. Next. Where? Next. Position. Yes. Keep going. R equal to. I love it. Where? Position. R equal to what? PG. Great, thank you. Point guard. Okay, so when I've done that, I will get a table consisting of what? Every single point guard and nobody else. Yep. Okay, now what do I want? The salaries have to be above 15. Yes? So on this table, you do what? Another where. Okay, I think you got this. So what's on there looks slightly different than what was said. NBA.where, you said position, we wrote 1. Is that okay? Yes, it's index 1. You said R equal to PG. We just wrote PG. Is that okay? That's okay. Equal to can be done in 2 ways. This is the more compact one, and the only reason for doing this, rather than R equal to, as was suggested there, was we couldn't fit it in the line. Okay, so where then salary R above 15, and now dot column. Which column? Well, you want the column of the names, and hence column 0. Good? Okay. So now I'm going to give you 2 expressions, and I'm going to ask you what will be the output. We're going to run these 2 expressions. And I need to explain what is going on here. You see that samosa there? That's not me being dreadfully Indian, right? This is not samosa that is the delicious Indian deep-fried savory snack. This is Professor De Niro's dog. And he created this example last time, and I like that dog, and I love the example, so I've kept it. Okay, so what we're imagining is the NBA needs a mascot, and they have chosen Samosa the dog to be their mascot at $100 million a year. Okay. So that row has been appended to the NBA table, and now samosa is often referred to lovingly as Samo, and so then the next thing is, okay, so look at NBA where the names contain Samo. If you run these 2, okay, NBA is the table described above. If you run these 2, what is going to happen? Talk to your friends and neighbors. No, don't watch that. That's just me doing what you asked me to do before. Right when I tell people not to watch something, all the talking dies down and they start watching. Okay, so am I going to get a table that has the row samosa mascot 100 and other rows? Is that what I'm going to get? Yes? Yes? No? Maybe? No? What do you suggest?
We won't because we haven't assigned.
Yeah, no, keep going, kid.
Assigned it to NBA. Like we created.
Fantastic. Okay, terrific. So here is a suggestion. We're not going to get that particular row because we haven't assigned this line to NBA. That line there is just a transient thing. Well, let's check it out. Okay, so I need to read NBA. NBA looks like that. By the way, you asked me to do this last time. And so the point guards that earned more than 15K that year, 15 million that year, were these people. Noticed the absence of a very well-known point guard. That point guard was not making 15 million that year, but you can bet he is now. And if you don't know what I'm talking about, it really doesn't matter from the point of view of this analysis. All right. Okay, so these are the two lines of code. We're going to run them. And we get a table, but it has no rows, right? It does not have a row samosa mascot 100 because we didn't assign that to the name NBA. That's just sort of sitting there waving in the breeze. So if you want to use that thing, you have to give it a name. And we didn't give it a name. Now, it turns out that in the original NBA table, nobody's name contained the letters SAMO. Because had somebody's name contained the letters SAMO, we'd have got those rows. But not the new row that we entered. I can change this. Dramo worked, Samo didn't. All right, good. So you can see that you have to keep a bunch of aspects in mind before you try to figure out what's going on. And what you're going to have to do is when you do your own analyses and you expect something to happen and it doesn't happen, these are the kinds of decision processes you have to go through in your head. All right. Okay. For the first time, I see some empty seats in the room. Even if those people were sitting in those seats, this would not be full. Almost full, but there would be some empty seats. So please, ladies and gentlemen, here's what you have to do. Figure out which seat you're in. That's on the seat. Figure out which row you're in. Ask the person next to you if you don't know which row you're in. Go to that URL. tinyurl.com may be attendance because my poor GSI got so tired of me never doing attendance. There's a little form for you to fill out. That form, pause a moment please. That form includes a question about tables. That is not a test. You may talk to your friends and neighbors. How many people have been able to get hold of the form? How many people have not been able to get hold of the form? Interesting. Interesting. Try logging into your Berkeley accounts. Yeah. Oh, whoa, excellent. Wi-Fi isn't working because we have maybe really maxed out the Wi-Fi use in Wheeler. We'll give it a couple of minutes. Thank you for pointing that out. 750 people trying to access the Wi-Fi. Those white boxes are being put to a lot of use. Okay, now how many people have the form? How many people don't have the form? Okay, let's keep trying. Those who have the form, do what I ask you to do. Okay, anybody still without access to the form? All right, all of those people, do you have access to internet at all? No? Do you have any paper? The people with no access to the internet, do you have any paper? No internet, no paper. Okay. Can you talk to the person next to you and see if they have some paper? Because if you did not get the internet, what I'd like you to do is the following. Your name, your SID, on a piece of paper, sent to me right now. The rest of you, got the internet? Filled out the form? Can we finish this? Let's try to finish this. Right. That's how you answered. So the majority response was, I can see one of them, where position is point guard. So what are we asking for? We want a table. So we want table operations. The last one better not be column. Okay. So we want the NBA point guard, fine, who earned the highest salary. So where position are equal to point guard, looks good. Sort, salary, I can't see it here, but I can see the D. Descending equals true. That looks good. Yes? Because you want to get the highest earning, the highest salary on the top row. And then there was a take. Yes? So which index do you have to take? Top row. You have to take index 0. And your choices were np.area. Sorry, was that a question? The form did not accept it? Right now I closed it. That's okay. Okay, if you feel that you did not get attendance and you are here, here's what you do. Everybody. Some people didn't get attendance because they couldn't log on at all. Piece of paper, analog. Piece of paper, name, SID. Pass down the rows and somebody pass to me. Don't get up. All right. But we were in the middle of a discussion. We want index 0. Your choices were np.arange 1 and np.arange 0. Which one did you take? np.arange 0 or np.arange 1? Okay, got both answers. Okay, let's see. That's good. np.arange of an integer gives you the integers 0, 1, 2, 3, 4, up to right before the one you selected. np.arange 1 therefore gives you the integer 0. np.integer 0 doesn't know what to do. It gives you the empty integer. That gives you the empty array. So this was asking you to check that thing. Okay, so one of the things I'm learning is that we stress out the internet in this room. We will respond to that one way or another. I'm just worried that in our effort to do this, we probably brought down the internet all over campus. We'll see. All right. It is time to do some data analysis. So the decennial census is when every 10 years, the U.S. government counts how many people there are in the United States. In between those, so there's a 2000 census, a 2010 census, and the next one is going to be the 2020 census. In between, the Bureau estimates how many people there are in the United States. It's very, very difficult to do this. There are a lot of people in the United States. And counting them is a lot of work. It costs a lot of money. Why does the government do this? Why does the government do this? Anybody? Yeah. Was that a hand up? What was your answer? I'm sorry? It's in the Constitution. Why is it in the Constitution? You're right, it's in the Constitution. Something's in the Constitution anyway. Yeah. Yes, to know how many representatives to give each state. Apportionment. That is why. It's about representation and it's about money. You know what's interesting is I'm looking at these numbers that were here, and it sure wasn't that number of hands up. Okay. Yeah. So Article 1, Section 2 of the Constitution, representatives and direct taxes shall be apportioned among the several states according to their respective numbers. All right? So you need to count people. And so what we're going to do is we are going to look at the census. Okay, guys, in the future, just pass these down the row, and then somebody in the front can do it so that lots of people don't have to do this. All right. So the census makes its data public, at least in aggregated form. And so this table here, we read from the Census Bureau, and that table looks like this. So this is population data broken up by sex and by age. This census 2010 pop, that is the numbers that were counted in the 2010 census in that particular sex group and that particular age, and we have to figure out what all those numbers mean. That's the 2010 population that was counted. There is also an estimate made in 2010 at a different time. And then there is 2011, 2012, 2013, and so on. And so there's a whole lot of numbers there, and data kind of look like this. Lots of numbers swimming in front of you. We will not, and you should not, work on such a large table at once. We should mess around with some portion of it. So we are just going to restrict ourselves. We are going to look at what is this? Why is this happening here? Much better. We're going to use a partial table, that is the full table, and we are going to select. I'm going to select sex, here the sex column, the age column, and then I want 2010. I'm just going to compare like to like, so I'm going to compare estimates from 2010 and estimates from 2014, and I have to type in pop estimate 2010, which is really, really boring, so I'm going to use column indices. And now I have a partial table that is a little more manageable, but I still don't like these headings, so I'm just going to call this guy 2010, and then what am I going to call the other one? 2014 seems reasonable. Actually, no, I'm not going to call it partial again. We're just going to call it simple. I'm trying to do what was the same thing as is in your textbook here, just for the cleaning up. Okay, so I now have a simple table. I don't like it because I have all kinds of numbers here, and I can't see how big they are. So simple dot set format, and I have a list of columns, and I will, okay, much better. Number formatter and percent formatter you saw last time when we were doing the Minar table. Okay, so we have this, and what I'd like to do is just sort of, this is an exploration phase, I'm just messing around, right? I would like to see how old people get. So, ooh, they get really old. Really old. Lots and lots and lots of people who are 999 years old. Okay. Then there are lots and lots and lots of people apparently in the gender one is hard to understand. Which is the 0, which is the 1, which is the 2. Okay. So what happens if somebody gives you data? You need to go read the documentation for that data. Okay, so in the sex column, they classified 1 as male, 2 as female. Nobody was classified in any other way. 0 means everybody. The 0 column is male plus female. 999 age is everybody. All ages. That's why the numbers are so big. Okay, so in that drama about attendance, we didn't actually get to what we want to get to in census. That's okay. We have plenty of time. We are going to do census and charts on Wednesday. We'll blend the two lectures because they are blended anyway.
Sorry, they keep on dribbling in.